Welcome to episode 36 of Programming with Qt Widgets. In this episode, we'll talk about the class called QVariant and how it is used throughout Qt. Let's start here with some code. I'm sure that you, assuming that you're more than a few years old, have written or at least have read code that looks exactly like what's on the screen. It's a union. And first question to you is, once you don't pause yet, let me tell you the question before you pause, you silly. What is a union? Now you can pause. Okay, and the answer is, that's correct. It is something that can store either an int in this case here, or a double, or a char pointer. That is an implementation detail you're telling me there. What a union really is an abstraction that, for example, from the return of a function can return either an integer, or a double, or a char pointer. That's the key thing to a union. Question number 2. What is the disadvantages of a union? Pause. Okay, disadvantage of a union. Well, there's 2 disadvantages. I'll bet you that every time you've seen a union, you have seen code that looks like this. Here is your union again, but the union is it's in a struct called data. Might not always be the name, but the key thing is that you have your union and you have something that tells what is in that union. If I have a function that can either return an integer, a double, or a char pointer, it would be useful before I go and read that data to know what did it return. Did it return me an integer or a double? Sometimes I know from the context, it might be that it's a method that's called data, and if I ask for the name, then it will return me from the data method, the union of a char pointer. And if I ask for h, then return me a union with an integer in, or a double. And now you ask yourself, what a weird API is that? Why not just have name and h be the methods? Well, we'll see that in a few modules of Programming with Qt Widgets where we'll talk about model view. But already now, go and look up the API that you'll find in QAbstract item model. It returns you a QVariant from a method that is exactly called data. So that's problem number 1, that you need to know what did you pack into it. Sometimes, as I said, you might know from the context, but sometimes you need to take it and tag it with, as in this case here, an enum that tells us what is the data in that union. That's problem number 1. And what was problem number 2? Oh yeah, that's right. Problem number 2 is that when I hit this line 7 here, when I hit this closing brace, it's game over. It is no more addition to your unit. Your union. Yes. You just go to your editor and you'll open a line in between 6 and 7 and you'll add it there. Yes, I know. But if this union was located in, say, a library, let's call that library Qt, and then inside Qt there was this union and you wanted your own data type. So it could be an int, a double, a char pointer, or a mygizmo. How would you go around that? Well, you could go and edit Qt source code and compile it again, and that will be very popular, especially if you ship it on a lot of devices. Then you need to patch your Qt every single version of Qt, and you need to make sure that your customer have exactly your version. Not a very good solution. And that is where QVariant enter the stage. So QVariant is just like a union with those 2 flaws solved. The way that it does it is that it implements a union using some template stuff in C++. You don't need to really understand that, but you'll see a template here and there when you work with unions. So first of all, you can go to a variant and ask it for what data type is in there. And second of all, you can get your own data type into the Q variant. So it supports all the Qt value types. So that's QColor, it's QString, it's QPoint. All of those are supported out of the box. It supports implicit sharing. That's reference counting, which makes it fast. Possibly it's not really a key feature or key concern, but it supports your user's type. And let's just look at what does it look like to work with a union on a day-to-day basis. Variant, parent, Jesper, Q variant. While I practice that, let's have a small ad. All the cool kids talk about it. Rust, it's more safe. It's better concurrent. There's many benefits. But how do you go from your C code base onto Rust? Well, talk to us and we can help you. Q variant. Yes, so Q variant on your day-to-day use. Most of the time you'll actually get away with just providing your data type when you want to wrap it into a Q variant or wrap a Q variant around it by simply providing it to the constructor. And let me just go over here to the documentation. You can see there's a lot of stuff that you can construct with a basic parameter to your Q variant. I can get my value out again with a number of 2, whatever, 2 int, 2 string, 2 double, 2 QRect, so on, and I'll get my data out. And I can go and ask my variant, what data type do you have in there? And the variant will say, well, I have an int as a string, int. That's those classes that are supported out of the box with Qt. For non-core, so non-Qt core classes, and QRect is obviously coming from Qt GUI, I believe, so it's not supported there. So if I said 2rect before, then that was wrong. Anyway, for non-core and your own data types, the way that you work with them is that you simply take your data types that you want to put in there, and then you wrap it with qvariant : from value. Qvariant : from value is actually a templarized method. So if you wanted to do it 100% correct, well, this is 100% correct. If you want to do 100% accurate, you would write qvariant : from value less than qrect greater than, and then parentheses and this stuff here. But the way that C++ works, if it sees a qrect there and there's one of the temporized methods that takes a qrect template parameter, then ta-da, and you have a match. Actually, it's the constructor parameter that matches. Anyway, now I've wrapped this into qvariant, and I can go and get it out again. And this time I go and get it out using a method called value, and that's a temporized method on my type that I want to get out, and value qrect, and that will give me the rect out of it again. What is the type in there? Well, qrect. So sometimes, and that came as a huge surprise to me in one of my classes, you actually do not need to wrap stuff around like with a variant from value. So in model view programming, the data method that I was hinting before, you often return different types. So if you want to return a qrect, you could return it like this, but at least QColor, I don't know about qrect, but QColor has a built-in operator, parentheses, so parentheses close, returning a Q variant. So in those situations, all I can do is do assignment here with a QColor. I do not need to wrap it with qvariant : from value. And there's a link right here on the screen to a QWidgets and more episode where I talk much more about that little trick. That's one thing you must do yourself if you're using a qvariant with one of your data types, and that is to declare that meta type. Basically what it does is that it adds some temporized magic so that everything works behind the scenes. But what you do is that you simply, after you have declared that class that you want to be able to go into a qvariant, you write q_declare_ meta type, and you specify the name of the class up there, and you do that in your header file. For your custom types to be able to go into QVariant, you need to have a default constructor, a copy constructor, and a destructor, and they of course all need to be public available so that the magic, let's call it magic, the magic actually works for Qt. If you have your class inside a namespace, then say namespace foo, and then end of the namespace here, then the Q_declare_meta_type needs to be outside of any namespace. So you would here write Q_declare_meta_type foo : contact. So once you created that class and you have declared it using Q_declare_meta_type, then you can use it as we see on this slide here. I create a contact, I give it the name Peter, QVariant : from value contact. Now I have a QVariant, and I can take that variant and I can bring it over an API that returns a QVariant, for example. And then I can go and take that variant and I can unpack it again. I can say variant.value contact. Now I have a contact, and I can use the contact just as normal. I can test whether the data type in here actually can convert to a contact. So if I have in my code, for example, I'm referring to monies and percentages and so on. So I have classes for that. So can convert money, can convert percentage, and then I'll do different things. For example, in a delegate to a model view, depending on what type was returned from the model. There's one function that you might find in your source code if you're maintaining a larger application and that you're wondering why is it there. It's most likely there for historical reasons. But let me tell you the full story. If you are developing a complete new application, you can doze off for the next 2 minutes. It's this function here called QRegisterMetaType. And what that does is that it on runtime register this class here so that it can be used in Qt signal slot connections. And so it can be used with the property subsystem that we'll talk about in the next episode, but only in some odd corner cases for the property system, that is. But let's see what it looks like. So here I have a small example coming up. I have a sender, it's a Q object. I have a receiver, it's a Q object. I connect, the sender sends out a signal here, and the receiver receives that signal and prints out that it got it. So far, so good. I can connect, I create a sender, a receiver, I connect the two together, and what you'll see when I run it here is that it'll say, got contacts Santa Claus. So that worked out pretty well. Now, if I comment this one out and I compile it again, it'll say, hey, you forgot to call, where is it? QRegisterMetaType. Cannot use Qt connections, because what you might not have noticed is that it says Qt connection. And Qt connection, we talked a bit about that earlier on when we talked about signal slots. That's the signal is being marshaled down into a small package that is being put into the event loop of the object, or the thread that the object receiving it lives on. They are the same thread here, so it's basically just going through the event loop. But that's besides the point. The point is that if I forget this one, and I'm using a Qt connection, and here's the big and, I'm using Qt 4 macro-based style of signals and slot, then I need this QRegister. If I was, on the other hand, using, let's comment this out, if I'm using the Qt connection here, but this time with the Qt 5 way, namely the pointer to member function, got contact Santa Claus. So this works, and regular with the signal slot works. You can try it out yourself. The key thing is it's only when I'm using Qt connection and I'm using macro-based signals and slot, which you shouldn't be doing these days anyway. And then when I use the property system and I get something out of the property before I put it in, which is not usually a situation you'll be in either. So, but as you can see, it tells you, hey, you forgot to call this, And I actually think, now that I think about it, I think I'm telling you everything that it says here on the next slide. So let's just go over there. You need it whenever you use macro-based Qt signal slots, when you use a property API and you haven't already called QVariant from value to get that value out of the property. Well, very odd use case where you do not enter. You do not need it for regular QVariant users. You do not need it for regular or for Qt only classes, and it will complain if you forgot. So basically, the last 2 minutes, just forget about this. It will complain, tell you exactly what to do. But as I said, you might have some old code bases that you're maintaining where you see this, and I'm wondering, what is this about? And now you know. You're very welcome. At this stage, we've been talking for, I don't know, well, it's an exaggeration. I've been talking to myself, looking into a camera lens for the last 15 minutes. And you, on the other hand, have been sitting there saying, okay, I understand what you mean about this union and packing in, but can you give me some real examples of when do you actually need a QVariant? And let me give you a few examples here from the Qt API. Let's start with the model view. The model view is the interface between a table and the data for that table in the Q abstract item model and Q abstract item view and Q list view, Q table view, and Q tree view world. And we'll talk much more about that. And I'll bet you that you will definitely, if you haven't already, you will meet this monster of a class. And the Q abstract item model, if you go and look at the API for that, you'll notice that the way that you get data from the model to the view is that the view will ask a method called data, and it will ask for the data of an index. That basically what are we talking about? And I'm talking about row number 20, column number 7, and a second parameter besides the index, namely a role. And the role is display role if we want to know the text. It's font role, or whatever it's called, if I want to know the font. It's foreground and background roles and so on. And you might ask yourself, why not just have one, instead of one method, have 20 methods for each of those informations? And the answer is, well, sometimes you want to ask about your own roles. And it's a super cool way of stacking a number of models on top of each other, those models known as proxy models. I'll talk much more about that. And you can go to Qt Widgets and more. I've been talking a lot about these different models over there. But the key thing is that the method of Q abstract item model is called data, and it returns a QVariant. So depending on what you asked for, if you ask for the display role, then you would get a string back. It would be a variant with a Q string. But it might be, see, there's actually an episode in Qt Widgets and more where when you ask for the display role, I return a Q string list. And then I have some code involved in there that makes it possible for the view to go and pick the longest string that fits in the given column size. There's a link for the episode in Qt Widgets and more right here. But that means that the data method should be able to return a string, an icon, a color, a font, a string list, as in my example, any kind of data type. If you've ever done any QML programming, that's okay. You don't need to be sorry about or make excuses for having done some QML. You'll notice that the QML is full of properties, and that's what the property API is offering here. So in QML, you will say text colon and then some text, and that needs to go down to C++ level somehow, and it does so via the property text and the value being a QVariant. We'll talk more about these properties in the next episode. SQL access. There is a QSQL query that can return you the value that was read out of the database, and depending on what that column in the database was, it could be different types. QVariant again. Q settings. You have a set value in QSettings. So QSettings is this mechanism where you store things into the settings database, and you can add a number, Boolean, or whatever, and the API just say set value, QString, and then a Q variant here. And again, you could ask yourself, why not just have a set value QString bool, set value QString, QString, and so on, have that set value overloaded? But that's because that the QSettings API, I'm not 100% sure, but I think that there is a mechanism for actually plugging in so that you can serialize your own data in here, depending on the particular variant. DBus, that's a way of doing inter-process communication. There we have Q variants again. Q signal slot marshalling, as we saw before. You need to take that data. You need to put it down into something that can go to a slot on another thread. How do you get that stuff packed down? Again, the Q variant. And that's it for this episode of Programming with Qt Widgets. In the next episode, as I said, we'll be talking about properties. So until then, have a great time.